So now that you've seen the definition of a sequence, here's some examples where we actually crank out the first four terms of a certain sequence. So remember, a sequence is a function whose domain is the set of positive integers. If we want the first four terms in this sequence, all we need to do is plug in n equals 1, n equals 2, n equals 3, n equals 4. So in this case, first term, when we plug in n equals 1, we write that as a1 will be 4 plus negative 1 to the first power, which will be 4 plus negative 1, so that's 3. So if I'm listing the terms up here, first term is 3. N equals 2, so that'll give us a2, which is 4 plus negative 1 to the second power. Well, that'll be 4 plus positive 1 when you square a negative, so 5. So the second term up here in the list is 5. N equals 3, so third term we plug in 3 for n, so negative 1 to the third. So, negative 1 to an odd power will be negative 1, so this is 4 minus 1, so 3. Third term is 3. Fourth term, a4, 4 plus negative 1 to the fourth power, which is an even power, so that's going to be positive 1, so it's 5. So it looks like this sequence is just generating the values 3, 5, 3, 5, 3, 5 forever. Whenever n is even, you'll have 4 plus 1, so you'll get 5. Whenever n is odd, you'll have negative 1, or 4 minus 1, so you'll get 3. Okay, so that's our first example. Second example, we'll keep this stuff, is, actually I have to check the notes here, it's defined as Bn equals n squared over 2 to the n minus 1. Is that right? Yes. Okay. So again, we just plug in n equals 1, n equals 2, and so on. So n equals 1. That gives us b1 will be 1 squared over 2 to the first minus 1. So that'll be 1 over 2 minus 1, so 1. First term in the sequence is 1. N equals 2. So b2... Sorry. So Sunday, the kids are around. N equals 2. So plug in 2 for n squared all over 2 to the second minus 1. So plugging in 2 for the n's here will give us 4 over 4 minus 1. So 4 thirds is the second term. N equals 3. I think you probably get the picture, but b3 will be 3 to the second over 2 to the third minus 1. So that'll be 9 over 8 minus 1 is 7. So 9 over 7 for our next term. Last one, b4, will be 4 squared over 2 to the fourth minus 1. So 4 squared is 16, 2 to the fourth is also 16, minus 1, so 15. So 16 over 15. Okay. And it'll continue from there. Okay, one thing that's different here with example 3, so I'm going to erase this. The third example is defined differently. Now I want to give you an example of a recursive sequence. A recursive sequence is a sequence whose terms are defined in terms of the preceding terms. So recursive sequence, in this case, suppose you're told that the first term, C1, is 24, and any consecutive term Cn plus 1 is equal to the previous term Cn minus 4. So in this case, I mean, we're just told straight out what the first term is, 24. This time to find C2, so if I'm looking for C2, that's going to be the preceding term. So whenever we want to find Cn plus 1, it's Cn, which would be the preceding term, in this case 24, minus 4, so 20. C3 will be the preceding term, 20, minus 4, so 16. And so the terms in this sequence, this was the previous example, will be 24, 20, 16, and you get the idea, 12. We could continue further. One really famous recursive sequence is the Fibonacci sequence, which let me throw on the board here real quick. In the Fibonacci sequence, well, the terms are 1, 1, 2, 3, 5, 8, 13. You might notice the pattern here. Each term is the sum of the two preceding terms. So one way to express the Fibonacci sequence, if I wanted to write it similarly to the way I introduced this one, I could say A1 is 1, A2 is also 1, and AN plus 2 is equal to AN plus 1 plus AN. Oops, this is an N. The sum of the two preceding terms. But so your answer to this example number 3, or I think I called it C in the notes, is these first 4 terms.